Gravity. The silent force that keeps us grounded, holds the moon in orbit, and commands the planets to dance around the sun. We know its rules. The farther you are from an object, the weaker its pull. This law shapes everything from Mercury's quick orbit to Neptune's slow journey. Astronomers expected this pattern everywhere, even in the swirling arms of spiral galaxies. Imagine a galaxy as a spinning record. The dense center pulls hardest, so stars near the edge should move slowly or risk flying off. The visible matter, stars, gas, dust, was thought to be the main driver of galactic motion. The universe seemed predictable, its beauty a testament to gravity's reliable nature. But the cosmos is full of surprises. Sometimes, the most basic truths are the ones waiting to be challenged. All it takes is a curious mind to ask, what if we're missing something? And that's exactly what happened. In the 1970s, astronomer Vera Rubin set out to measure how galaxies spin. She expected to confirm the familiar patterned fast stars at the center, slow ones at the edge. But her data from the Andromeda galaxy defied all logic. The outer stars were moving just as fast as those near the center, something gravity alone couldn't explain. Rubin checked other galaxies. The result was always the same. Everywhere, the outer stars sped along at impossible speeds. This became known as the galaxy rotation problem, a crack in the foundation of astrophysics. The universe wasn't behaving as it should. Rubin's discovery suggested that everything we see, stars, planets, nebulae, is just a tiny fraction of what's really out there. Galaxies, it seemed, were embedded in something vast and invisible. Her work forced science to confront a startling idea. The cosmos is dominated by a mysterious, unseen substance. The search for answers had begun, and the universe would never look the same. To explain Rubin's findings, scientists proposed a radical idea. Galaxies are surrounded by halos of invisible matter. This dark matter doesn't shine or reflect light, but its gravity shapes the cosmos. It's the hidden scaffolding holding galaxies together, making up about 85% of all matter in the universe. The stars and gas we see are just decorations on this vast, unseen structure. Dark matter's influence extends far beyond galaxies. It's the architect of the universe's large-scale structure. In the early universe, dark matter's gravity pulled ordinary matter into dense regions, seeding the cosmic web. Galaxies formed along these invisible threads. Though we can't see or touch it, dark matter explains why galaxies don't fly apart and how the universe evolved. It's become a cornerstone of modern cosmology. For decades, it's been the best explanation for many cosmic mysteries. But the search for its true nature continues, and new evidence would soon put the theory to the test. To probe dark matter's reality, scientists turn to the universe's oldest light, the cosmic microwave background, or CMB. This faint afterglow from the Big Bang is a baby picture of the cosmos, showing tiny temperature fluctuations. These small differences were the seeds of all cosmic structure. The CMB's patterns only make sense if the universe contains a huge amount of invisible matter. Ordinary matter alone would have smoothed out these fluctuations. But dark matter, unaffected by light, began clumping early, shaping the universe's structure. The CMB is one of the strongest pieces of evidence for dark matter's existence. Yet, as we looked deeper, new mysteries emerged. For decades, dark matter explained the cosmos's structure, but science thrives on new questions. In 2021, the James Webb Space Telescope launched, designed to peer back to the universe's first galaxies. Webb is a time machine, capturing faint infrared light from billions of years ago. Scientists expected to see small, clumpy galaxies slowly forming in the early universe, just as dark matter models predicted. Decades of research and simulations pointed to this. But when Webb's first images arrived, the universe had a surprise in store. What we saw would challenge everything. Webb's deep field images revealed a universe packed with galaxies, large, bright, and well-formed, just a few 100 million years after the Big Bang. Some even looked like mature spirals, far too developed for their age. According to dark matter theory, there hadn't been enough time for such structures to form. It was as if we found adults in a nursery. These findings shook the scientific community. If galaxies could form so quickly, maybe dark matter isn't the slow guiding hand we thought. Or perhaps gravity itself behaves differently on cosmic scales. The Webb data forces us to rethink our timeline of the universe. The CMB says dark matter must exist, but the first galaxies say it doesn't work as we expected. We're left with a contradiction at the heart of cosmology, and the search for answers grows more urgent. This contradiction has opened the door to wild new ideas. Maybe we're missing a fundamental piece of the puzzle. One theory suggests our universe is a three-dimensional brain floating in a higher dimensional space. Gravity, unlike light and matter, could leak into these extra dimensions, changing how it works on large scales. This might explain the strange motions in galaxies. No dark matter required. Perhaps the extra gravitational pull comes from the geometry of a larger reality. The dark matter we seek could be a shadow of higher dimensions. It's a bold idea, but one that serious physicists are now exploring. The James Webb Space Telescope hasn't given us tidy answers. Instead, it's reopened the greatest cosmic mysteries. We're at a turning point, much like when Vera Rubin first glimpsed the unseen. The impossible galaxies of the early universe force us to question everything. Maybe our theories need refining, or maybe reality is stranger than we ever imagined. The search for dark matter continues, but so does the search for new ideas. We're explorers, sailing into uncharted waters. The possibility of higher dimensions is no longer just science fiction. Each discovery brings deeper questions, and the journey of understanding is far from over. The cosmos keeps its secrets well. But with every new glimpse, we get closer to the truth.